All right, 2.1, number 26. This one's tricky, this revenue problem. So here's a quick look at the way this gets analyzed. There's two parts of the problem. There's money you take in, so there's money, or I'm sorry, the number of cans. This is a selling cans deal, or number sold. There's a quantity piece. I'm going to put that in quant. And that's part of the problem, times actually the price that you sell it at, so quantity times price. That's actually the idea of revenue. And this problem snuck up. I didn't know if this was in there or not, so I'm glad you brought this up. Revenue equals quantity times price. And if you look down here, the quantity is, so you start with selling on average 23,000 cans per month, and they sell for 50 cents each. Now, for each nickel increase in price, the sales drop by 1,000 cans. So you're selling 1,000 cans so long as we don't go over multiples of 1,000. So each can you drop over 1,000. Let's see, for each nickel increase in the price, the sales per month drop 1,000 cans. And so that little piece tells you the number of cans you're selling. You lose 1,000 cans for nickel price increase. That X happens to be the nickel price increase. And if you look back up here, it says it in this part A up here. X is the number of 5% increases in the price of a can. So that's how many you'd sell, depending on how many price increases you put in there. The next one is the price that you actually sell. You start at 50 cents. Like, that's what we charge, 50 cents a can. Unless you do these nickel price increases, you start throwing those in the mix. Now, you're going to make more money. If you increase the price per can, you're going to make 5 cents more per can, depending on how many you sell. Well, conversely, though, selling at a higher price, people don't want as many, so you lose the total number sold. Together, it's kind of, you're finding a balance. You're trying to find, when do I just make the most money under this circumstance? This is legit. You increase the price, people don't buy as many, but it can be good because a higher price just brings in more money by default, even though you may not be selling as many cans. If I go to the next page over here, here's a graph of that function. So here it is again. And if you use that maximization function, you do your left bound, your right bound, and then guess, your calculator will give you something like this, 6.5, 13,612. What this X represents, remember, is the number of 5-cent increase in cans. So this is number of those 5-cent increases. So I got 6.5 5-cent increases. The question in the final part that I think is kind of tricky is, what's the price of the can you're going to sell it at? Well, this graph is the number of 5-cent increases. The actual price you're going to sell it at, remember, is this left or the right-hand side of that function. So the selling price is you're going to get from that 0.5 plus 0.05 times 6.5. Because that's the number of 5-cent increases you're going to put in there. What you're going to get is 82.5 cents. And the problem says round to the nearest whole number, so you go 83 cents a can. Your maximum profit or revenue is going to come from an 83-cent can. So I'm going to go back a little bit here to my previous page, if I can do that. It's hard to find this thing. So the next problem down, you can't see it on this sheet, but just down there, that's the best price to sell at, is 83 cents. Then it asks you, what's the revenue you take in for selling at that price? Well, that's the 13,612. This is actual revenue taken in. That's rev. So those are the values you get. Actual height. And the way this graph comes out, X is the number of 5-cent increases on that can. So hopefully that helps you finish that out, answer that question. Please email with other questions. Stop by. I'd love to help you out.